recording. So in today's lecture, what we'll be looking at is just kind of give you an overview of the course, what you need, how you'll be graded. And then I'll give you a brief kind of look at the format on Blackboard. And then I have a few, I guess you can call them review slides from Gen Chem 1 that we're going to go through and kind of refresh your memory to get you prepared for intermolecular forces in chapter 12. So if you took general chemistry at UTSA, general chemistry 1 at UTSA, and you bought a multi-year license for Connect, you can use that same Connect access code for Gen Chem 2. So if you took Gen Chem 1 in the summer or in the spring or even the fall, and you bought they have a 3-year access code. If you still have that access code, you can use that same code and get access to Connect. So make sure you do this. If you don't have the access code, you can go to the bookstore, or even when you're registering for Connect, they give you options to purchase from the publisher. They have a 1 semester access code plan. Now the cheaper version, and those just joining us, make sure you put your mic on mute, please. The cheaper version of the different plans on the bookstore is just the Connect access code, which comes with an ebook. The more expensive plan is the access code, and if you want a physical textbook that we'll be using in the course. So that's the difference between the plans. One is just the access code, which comes with ebook. The second one is an access code with ebook and a physical textbook. But if you want to just get the access code, you're more than welcome to use an older edition book or another general chemistry book as a reference for the course. And you will need actually a non-graphing calculator. It's not non-scientific. So like a TI-30 is the preferred calculator for this class. So that's what you need. There's no iClicker used. We don't use any iClickers because it's all online. No. So I just kind of went through how to register for Connect. You just click on any Connect assignment or any tutorial, and you'll be able to register for Connect. You have to register for Connect through Blackboard, and keep your questions at the end, and when I pause, we'll take questions then. So there will be attendance for this class. It's just 2% of your final grade, and the way you get this 2% is to attend a minimum of 3 of these virtual sessions, not counting today. Today doesn't count. But I recommend you attend as many as you can, but the minimum you need is 3. And the way I'll take attendance starting on Wednesday is I'll give maybe a 1-question quiz during the virtual session, and it'll come on Blackboard. I'll say, okay, go now to Blackboard, do the 1-question quiz question, and you'll answer it. Whether you get it right or wrong, it doesn't matter. It's not for a grade. It's just merely to take attendance. So as long as you get your 3 sessions, you get your 2% final grade. And that's 3 sessions over the course of the whole semester. So there's 40 classes almost. So what type of assignments? So if you had Miss Gold for Gen Chem 1 in the summer, similar assignments we'll have in Gen Chem 2. So there'll be a Learn Smart assignment, which is like a reading assignment. So you'll go through, you read, you'll get to a checkpoint, you answer the questions at the checkpoint. If you get them right, you move on to the next section. Now these Learn Smarts can't be submitted late. They have to be submitted by the due date. The other type of assignment is the homework problems. So for each chapter, there's a series of homework problems for you to complete on Connect. And you get 3 attempts, and you have to make a 70 or better on the Connect homework to access the Connect chapter quiz. All of the homework and Learn Smarts assignments are due at 8 a.m. on the day of the corresponding exam. So you look at the exam dates, that's when your homework set 1 assignments will be due. In addition to these assignments, we'll be having a weekly homework assignment, which I'll post either today or in the morning, and that'll be over topics we're going to be discussing that week. And those will be due at the end of the week on Friday at 5 p.m. And this will just be 5 questions approximately that I'll post on Blackboard to go over the topics that we'll be discussing in that week. So this week we'll be discussing intermolecular forces, so that's what these questions will be. And I'll post them either today or the latest tomorrow morning. So for the quizzes, there's no in-class quizzes. I apologize. This is from last semester. We just have our Connect quizzes. Again, you have to make a 70 or better on the corresponding homework to attempt the quiz. And these Connect quizzes are also due at 8 a.m. on the day of the exam. And the reason they're due at 8 a.m. on the day of the exam is because at 10 a.m. on the day of the exam is when your exam will be available for you to take. So that's why we make them do at 8 a.m. So let me go through one more slide and then I'll take some questions. So how will you be graded? There'll be 4 exams. Be 40% of your grade. We have a comprehensive final exam, which is approximately 28%. Attendance is 2%. Quizzes are 20%, and those are just the online quizzes. And then we have our homework, which is 10%. So the first items to complete, make sure you read over the syllabus. You'll need to do the General Chemistry 1 review. You have to make a 95 or better to access the Chapter 12 assignments and also Chapter 13 assignments. And so, once you do the review, you can start working on the Learn Smart and the homework assignment for Chapter 12. That's what we'll be covering first. I recommend doing the Learn Smart first because it's like a reading assignment. So it kind of introduces you to the topics and then working on the homework as well. Okay. So at this point, I'm going to pause recording. So in Chapter 12, we're dealing with intermolecular forces, phase changes, how much heat it takes to say, for example, raise 50 grams of ice from negative 15 degrees Celsius to say 30 degrees Celsius. And so that's what we're looking at states of matter, intermolecular forces, and what we need to refresh from Gen Chem 1 is Lewis structures, molecular geometry, polar, non-polar molecules. So this should ring a bell to you when I say these words, because whether something is polar or non-polar is going to have an effect on its intermolecular forces. So you'll have to be able to draw Lewis structures and determine what type of geometry it is, because based on the geometry, typically you can determine what type, if it's polar or non-polar. And once you know it's polar or non-polar, you can assign the correct types of intermolecular forces. So I just pulled some review questions that I usually use. And so here we have the ion ClF3 plus 2. And so just to kind of recap on drawing Lewis structures. And so the first thing you need to do is determine the total number of electrons. So here we have our total number of valence electrons. We have Cl and F. They both have 7 valence electrons, so it's a total of 28 electrons. Well, if you download the lecture notes, you can follow along as well.
Vamos a hacer pipí.
And so since it's a +2, we're going to subtract 2 electrons from the total, and we get 26 electrons. So now we have 26 electrons. We're going to draw the Lewis structure. So we put chlorine in the center. And we put the 3 fluorines around it. And so remember, the ones on the edge get 8 electrons. I'm just showing you all the steps, but some of you may identify the geometry quicker. That's all right. So we have 26 electrons. So now we want to determine the type of molecular geometry. So here it has 3 bonding pairs and 1 lone pair. And remember, since it's an ion, we have to put it in brackets. Like that. And so if it has 3 bonding pairs and 1 lone pair, the type of molecular geometry it is a trigonal planar, or excuse me, trigonal pyramidal. So that has 3 bonding pairs, 1 lone pair. So now I like this question because one thing unique about my Gen Chem 2 class is I incorporate a lot of applications for organic chemistry. For those of you who are going to continue with organic chemistry, I help prepare you at least for the first exam. We cover a lot of the stuff on the first exam of organic chemistry throughout the whole course in general chemistry too. So it kind of prepares you for organic chem. So I like to incorporate a lot of applications to explain the concepts that we're talking about. So we'll go through this, I'll explain it, and then we'll stop and we can ask questions at the end. So here we want to know we have a series of organic compounds, and we want to know which of the following would have a 0 dipole moment. And so if you remember from Gen Chem 1, 0 dipole moment means it's going to be nonpolar. So when you look at these molecules, you want to see, okay, which one of these would be nonpolar? Those are the ones that are going to have a 0 dipole moment. So now if we look at each one in depth, we see here first we have chlorobenzene, which means we have a chlorine attached to a carbon. And each one of these little intersections you see here is a carbon atom, and it's understood that a carbon atom is there. And so what you need to remember is that each one of these intersections, there's a carbon atom, and carbon likes to have 4 bonds like a cat has 4 legs. There's actually a professor in organic chemistry, she has a cat named Carbon. And so when you look at this position here, you see that carbon has 3 bonds, but it wants 4. So that tells you it's understood that there's a hydrogen that comes off here. These are called the skeletal structures of these compounds. So anytime you see an intersection or a terminal stick, I call them, you have to make sure it adds up to 4. So whatever it doesn't add up to 4, you add a hydrogen to make up the difference. So each one of these has a hydrogen off of it. And it's just if you take organic chemistry, this is the common way to draw molecules. All right. Now back to the task at hand. So here, this is a carbon, and this is a chlorine. So this is a polar bond with the dipole pointing towards the chlorine. So since it has a dipole moment, aka a polar bond that doesn't cancel, this is a polar molecule, so it would not have a 0 dipole moment. Next, we go to meta-dichlorobenzene. And so here we have 2 carbon-chlorine bonds. And they're both polar. And the way we know we point towards the chlorine is because chlorine is more electronegative than carbon. Now, if we overlap these 2 dipole moments, you see that they do not cancel. So since they do not cancel, this is a polar bond. So that tells you there's a net negative charge in this direction and a net positive charge in this. And that's where you get a polar molecule. So since it's polar, it has a non-zero dipole moment. Now we go to toluene. You see here we've replaced the chlorine with a carbon. And so this is a carbon-carbon bond. And you see the only thing that this molecule has is carbons and hydrogens. And if you remember from Gen Chem 1, any compound that just contains carbon and hydrogens is non-polar. So since it only contains carbon and hydrogens, it's non-polar. So this one would not have a dipole moment. It would have a 0 dipole moment. So toluene is non-polar, which means it has a 0 dipole moment. And again, it's non-polar because it only contains carbon and hydrogens. Next, we go to para-dichlorobenzene. Again, we have this carbon-chlorine bond, and the dipoles point towards the chlorine because chlorine is more electronegative than carbon. So now if we overlap them, you see that the negative of one cancels out the positive of the other. So here these would cancel out, so this would be a non-polar molecule. And since it's non-polar, it would have a 0 dipole moment. Now again, we have to be comparing apples and apples. It's a carbon-chlorine on both sides. Now for example, if I change this chlorine to a different atom, say fluorine, then the dipoles would have different magnitudes. It wouldn't work. So we have to be comparing the same types of bonds because they have the same magnitude of dipole moments. Lastly, we have orthodichlorobenzene. Again, we have this carbon-chlorine bond. So the dipoles point towards the carbons, or excuse me, the chlorines. Now here again, they don't cancel out. One points that direction, and one points this direction. So you get a net negative charge on this side and a net positive charge on this side. So this would be a polar molecule. And so the two that would be 0 dipole moments would be C and D. Because they're both nonpolar molecules, they're going to have a 0 dipole moment. So in this question, we want to know which of the following species are not polar. Select all that apply. So in order for something to be not polar, when you're looking at different molecules or the molecules with one central atom and the same terminal atoms around it, we know that when there's no lone pairs, for most cases, they're nonpolar. When they have for sure an odd number of lone pairs, it's going to be polar. Likewise, so based on the geometry, we can determine if something is polar or nonpolar. So for example, if we take selenium tetrafluoride, if we draw the Lewis structure, I'm just going to draw it so that we can see whether it's polar or nonpolar. And I didn't put the electrons around the fluorine just for time's sake. So this is the Lewis structure of selenium tetrafluoride. So it has 4 bonding pairs and 1 lone pair of electrons. So anytime you see a molecule with 1 lone pair of electrons, that's a good indication that it's a polar molecule. So selenium tetrafluoride is polar. Next we have tellurium hexafluoride. Let's see. So with tellurium hexafluoride, it would look like this. There's 6 fluorines around the tellurium. And since there's all bonding pairs of electrons around the tellurium, and they're all the same type of atom, they're all fluorines, this would mean that this molecule is nonpolar. So anytime you just have non-bonding, or excuse me, you only have bonding pairs of electrons around a central atom and they're all the same type of atom bound to the central atom, it's a nonpolar molecule. Yeah, this right now is just a review to get us thinking about Lewis structures and polarity, because the next lecture will be about intermolecular forces where we need to utilize this polar nonpolar. So next we have CH2, C2, H2, Cl2, and it's the cis isomer, and we want to know whether it's polar or nonpolar. And you should have touched on this in Gen Chem 1, between the difference between cis and trans. So cis means that the 2 chlorine atoms are pointing in the same direction, and trans means that the 2 chlorine atoms are pointing in opposite directions. So obviously if one is polar, the other one's going to be nonpolar. So let me draw those 2 for you. So in this first one, we've drawn the trans form because the chlorines are on opposite sides. T for trans. And then we draw the cis form. In the cis form, the chlorines are on the same side. And so if we look again, chlorine is more electronegative than carbon, so the dipoles point towards the chlorine atoms. Now you'll notice in the cis form, the dipoles don't cancel, but in the trans form, since they're on opposite sides, they cancel each other out. And so whenever you have cis and trans, the trans is always nonpolar and the cis is always polar. And so what this means is when you have cis and trans, cis would have the higher boiling point, trans would have the lower boiling point. So the cis is polar, trans is nonpolar. And then NH3, ammonia, we draw its Lewis structure. Again, it has 1 lone pair of electrons. It's going to be a polar molecule. Now with ions, ions technically cannot be nonpolar because they're going to have an overall charge with their polyatomic ions. So F and G cannot be nonpolar because there's an overall charge in the molecule. So only the trans of dichloroethene and tellurium hexafluoride are nonpolar.